To all, I am Yuga Shrirame, postgraduate student pursuing Masters in Construction Engineering and Management at SEF University. My student code is PCM25394. So, as a part of the studio of construction project execution, monitoring, and control, the studio involves understanding of the construction methodologies by observations from the site, sequencing of the activities, how the coordination between the stakeholders goes in actually on site and the real-time site challenges. And this execution part was further followed by the monitoring and control aspects as a part of the studio, wherein it included progress tracking, quality assurance, and also plan versus actual execution to evaluate the overall project performance and the efficiency. So, as a part of the studio, this portfolio focuses on the topic of the railway station elevated road. So now talking about the project brief, the railway station elevated road, it is a brownfield kind of development wherein it is aimed to be completed within 2.5 years. So the elevated road is 1.5 kilometer stretch. So this 1.5 kilometer stretch comprises of from P1 to P51, but there are other parts of the elevated road as well which comprises of the down and the up ramps, the two ROPs, which are the railway overbridges, and two drop-off points as well. So the scope of this portfolio is only limited to the elevated road, which comprises of P1 to P51. So for this stretch, it is aimed to be completed within 2.5 years under the EPC contract mode, which has a cost of 700 CR. So if we see again the phases of construction for the elevated road from P1 to P51, it is being executed in the three phases, which is phase 1, phase 2, and phase 3, which will be elaborated further. Now if we see in this image, to understand the project constraints and to execute the project efficiently, the surrounding infrastructure nodes which are crucial to be identified and during the initial phase itself so that the construction could be processed smoothly are done over here. So as we can see from P1 to P51 there is a live railway track running parallel to the elevated road wherein there is a current railway station. Along with that there is a new railway station being developed alongside it. There is a metro station exit over there. Also there is a high-speed rail project being executed simultaneously over there. So this is a very complex kind of project being executed. So to cater to all these site constraints, the planning methodology for to execute this project is planned in such a way that all the site constraints with respect to the surrounding infrastructure nodes, the ongoing construction as well as the density of the area with respect to the population, the mixed traffic conditions, and the urban density of the area located surrounding to the project are being taken care of. So the project is aimed to connect the two railway overbridges, which is the north and the south ROB. So due to this project, it will integrate multiple transport modes through grade separated elevated movement, so which will greatly help the railway passengers, the metro commuters, and also support the intercity traffic. So it will eliminate the need of going through the entire city and reaching the designated positions, like to access the railway station through this elevated road would be much easier rather than going entirely throughout the city, since currently there is no dedicated bifurcation to reach these points. So this will also improve the traffic circulation around the MMTH and reduce the bottleneck traffic around the station entry and exit points. So indirectly, it is providing a perfect east-west connectivity across the railway corridor without having the need of the surface level intervention. About the planning of ports with respect to how the ports will be executed during the construction phase. So to talk about the ports, there are three phases: phase 1, phase 2, and phase 3. Phase 1 is P1 to P21, phase 2 is P22 to P40, and phase 3 is P41 to P51. So within phase 1, which is from P1 to P24, it is further bifurcated into three phases, which is phase A, phase B, and phase C. Whatever the planning methodology is executed for phase 1 The similar will be executed for phase 2 and phase 3 as well. So in this slide, we have tried to explain the construction methodology for phase 1. So as we have seen earlier, regarding the key site constraints of this site with respect to the active railway tracks being the enclosed access roads or traffic congestion, all these have led to the restricted working blocks for the construction. So to cater to all these conditions, the pores are planned in the staggered and cyclic manner, wherein for phase A, first P1, which is the Pier 1, then Pier 3, Pier 5, Pier 7 will be executed first. Then P7, P2, P4 and P6, which is the alternate construction, is being executed for this. So based on this, the pore sequences are scheduled on MSP, and accordingly the labor and equipments are mobilized as per the planned cycles. So once the phase A is done, in this manner, similarly phase B and phase C will be executed, and similar pattern will be repeated for phase 2 and phase 3. So based on this, for the concrete planning, an on-site batching plant is proposed by us, wherein based on the work quantities and the MSP schedule, a batching plant of 45 cubic meter per hour is proposed by us. So this table shows a synopsis from the MSP, wherein we have identified the peak dates for phase 1, phase 2 and phase 3. So among all the phases, the peak concreting demand was coming in phase 2, which is from P8 to P13, wherein it was coming at around 19th, which is with a peak concreting quantity of 150 cubic meters. So the graph represents for the phase 1, wherein in the phase 1, as we can see, there is a peak concreting quantity of 96.11 cubic meters, which is arising due to Pier 2 and Pier 7 combined. And within Pier 2 plus Pier 7, which component is giving the peak concreting demand, which is the Pier of P2 and pile cap of P7. So these two combined together are giving us the peak concreting demand. So this is the analysis for concrete planning. For the formwork planning, there were two set of trials being done for the set code repetition for the formwork, wherein the first trial comprised of repetition for 3 sets of formwork of D1, D2, D3, and the second trial comprised of formwork repetition for 2 sets, which is D1 and D2. So from the analysis based on the scheduling based on MSP and the work quantities calculated by us, it was found that when we are opting for 3 set repetition, there were 2 such instances wherein clashes were occurring, that is simultaneous demand for formwork was being obtained. So there were clash for 3 days and clash for 1 day. So first instance was clash for 3 days and the second instance was clash for 1 day. So in all there was a clash for 4 days when we are opting for 3 set repetition. And when the trial was done for the 2 set repetition, there were 7 such instances being identified for clashes. So the methodology which we are going ahead with is for formwork planning is the 3 set code repetition for formwork. Similarly, when for the reinforcement planning, similar calculations were being done and the peak reinforcement quantity was identified due to simultaneous work being executed of Pier 18, 19 and 20, wherein peak reinforcement quantity obtained was 33 metric tons. So this was the analysis for formwork planning and reinforcement planning. Productivity calculations for the peak concreting demand. So for the peak concreting quantity of 150 cubic meters, the productivity was found out to be 1.25, which is the productivity per gang for per working hour for 1 cubic meter of work. So next for the just-in-time calculations for the transit mixer. The analysis here shows that for the peak concreting quantity of 150 cubic meters, there would be 3.32, which is around 4 TMs would be required, which is for if it is capacity of 8 cubic meters per hour. So the rate at which the TMs will be needed is 32 cubic meters per hour. So whenever there is a demand or pull from the system being generated for peak concreting operations, so here the table is trying to show the number of repetitions which would be needed if there is only one TM. So for the just-in-time calculations, the number of TMs which would be required will be 4, and for each such TM has to do at the max 5 number of repetitions of the fleets. So conclusion is that for peak concreting demand of 150 cubic meters, a fleet of 5 transit mixers is required to achieve effective just-in-time delivery. For the contracts administration, the project is being executed under engineering, procurement and construction type of contract, wherein the construction period specified was 36 months, and in the contract the scope of work was elaborated with respect to elevated road above the tracks, outside the tracks, and the elevated road ramps. So for the payment stages, which is based on the milestone payment basis, it is divided into two categories, which is above the track and outside the track, wherein the above the track category constitutes a major chunk of the contract value. Within the above track as well, the 42% of the payment will be received on completion of the launching of girders of the superstructure, wherein in case of outside the tracks, 40% payment will be achieved on completion of the pile works. Now, talking about the documentation of the hindrance of the site, a hindrance register was maintained, which showed that a majority of hindrance on the site was due to the physical hindrances, which were arise due to demolition of toilet blocks or demolition of boundary walls or several such structures which were being identified during the construction. So there were no clearances from the authorities received, due to which the delays were occurring in order to demolish these physical hindrances. So out of all the hindrances, ROW acquisition delay was also one of the concerning issues, even though it accounts a small part of it, but it was also the number of days due to which the project was delayed for ROW acquisition delay is also one of the concerning parts. So total delay of the project currently as on date was 1004 days, which is around 2.7 years. Now talking about the special conditions of contract, under which provisional sum of works was one of the peculiar features of this contract, wherein under the provisional sum of works, it is applicable when the work is identified but not defined in terms of quantity. So under the provisional sum of works, a dedicated budget or quantity is allocated to take care of such works which could arise during the course of the project. So for this project, the construction of the boundary walls or for preventing trespassing into railway stations, the shifting of uncharted utilities, and the elevated road, which comprises of P1 to P18 and P42 to P51, which is the outside the track part. All the works under this category were falling under provisional sum of works, wherein the chartered utilities are the utilities which are identified in advance during the bidding stage itself, so which comprised of the sewerage and stormwater drains, the telecom and power supply lines, and all other utilities other than this are taken care under the uncharted utilities. So this clause was put into picture specifically because there was a presence of workshops and dispensaries and small railway blocks around this P1 to P18 and P42 to P51, and there was no foolproof plan what to do about these utilities, and the alignment also in this section was not finalized at that stage. So to take care of all of this, a special condition of provisional sum of works under which a dedicated budget was allotted to take care of this condition. Also, there is one condition for the preservation of the heritage monuments, wherein the presence of the minarets around the project structure had to be taken care of. So as per this Prohibited and Regulatory Areas Act, 100-meter radius is to be maintained around this centrally protected monument. So to take care of this, under the project, the alignment was revised again and modified, wherein a semicircular diversion was given in front of the brick minar, and with the help of this diversion, a safe distance of 244 meters was maintained. So for the contractor, it is not possible to set up any facilities like material storage at batching plants or to carry out any construction or structural works around this area. Follow the price adjustment clause. The criteria for the price adjustment clause was which is required for contracts which have a duration of greater than 18 months, which the project is more than 18 months, and to adjust the price adjustment clause, it is based on the for the payments made in that respective quarter, the price adjustment is being applicable, and the formula for price adjustment which was specified in this contract was as per the similar mods projects being executed, a similar formula was used in that. So to take care of the fluctuations in the market prices of labor material like cement, steel, bitumen, fuels and lubricants, the price adjustment clause is being deployed. So there are current indexes and base indexes. So base month for this was August 2023, around which the project was bidded for, and the quarter for price adjustment considered is from the next month after the base month, which was September 2023 in this project case. So this basic rate difference due to the price adjustment clause is adjusted in the quarterly billing cycles of the project, and accordingly the compensation of the payment is being done to the contractor. Now here, under the change of scope criteria due to which extra items arise due to the change of scope, for this, in this project case, the root cause analysis for extra items which arise due to the change in the tender drawings which were provided by the client earlier, but due to the change in the alignment at the later stage of the project, as it is a EPC contract, the contractor had to revise the design drawings due to the change of the alignment. So under this, the claim was made towards the additional design and engineering charges which were incurred due to rework by the contractor. So for this, the root cause analysis is being done. In inventory management part, the lead time for cement was among the highest, which was of around 18.5 hours, and the material storage facility is a common facility which comprises of the works for the project of MMTH, the station building works and the elevated road. So among all the materials for the always better control, from the analysis it was found that the reinforcement alone accounted for around 58% of the total material cost, due to which it requires the highest level of control and monitoring, followed by which the bearings and the cement are the items which fall under the B part of the ABC analysis, which required moderate control, monitoring, and accordingly the planned procurement strategies for these materials should be executed. For the reconciliation part of the cement, the time frame for reconciliation considered is 1 month, and the methodology followed for the reconciliation of the cement is based on the MSP schedule. The activities which are being done under this period were identified. To come up with the theoretical quantities, the dimensions from the drawing were being taken, and for the actual consumption, the pour cut quantities were being taken up, and accordingly the actual and theoretical consumption were compared and the wastage was computed. For the economic order quantity, the analysis is being done on cement and coarse aggregates. The analysis on cement is being done using the classical EOQ model, and the analysis for coarse aggregate is being done with the price break model. So the analysis has shown that the ordering quantity of 321 metric tons has yielded the EOQ in case of cement with a minimum total cost of around 2.91 CRs. And in case of coarse aggregates with price break model, the ordering quantity of 1,822 metric ton has yielded the EOQ with a cost of around 1.98 CRs. So based on this analysis, the ordering cost, holding cost are being balanced, and the optimum is being found out at the intersection of these two curves, and accordingly the EOQ is being computed. The port planning, contract administration and the inventory management altogether covered all the three aspects towards which the studio was aimed, from execution, monitoring and control, wherein the port planning emphasized on the execution part of the project, and the contract administration being during the course of the project, filing the claims, taking care of the variations, monitoring the clauses, and the tracking part, which mainly comprised of the inventory management, being the lead time calculations or finding the optimum order quantity and the time at which the material needs to be ordered and the number of orders which will be done within a year, the tracking of the material. So all these three topics provided a broader insight to the aims of the story. Thank you.